Now let's talk about neural networks, which form the core of how models like ChatGPT actually learn. The idea of a neural network is inspired by the human brain. On the left side, you can see an image of a biological neuron, where signals travel from one neuron to another through connections called synapses. Artificial neural networks, or ANNs, are a simplified mathematical version of this idea. In an ANN, we have artificial neurons, also called nodes. Each neuron by itself is very simple. It performs a small calculation and then applies something called an activation function. An activation function decides whether the neuron should pass information forward or not. A very common activation function used today is called ReLU, which simply means if the value is positive, pass it forward. If it's negative, ignore it. The real power of a neural network does not come from one neuron. It comes from millions or billions of neurons connected together. Now, look at the diagram on the right. The data first enters through the input layer. This could be text, an image, or numbers, converted into a numerical form the network can understand. Next, the data flows through multiple hidden layers. These layers are called hidden because we don't directly see what they're learning, but this is where the real intelligence happens. Each connection between neurons has a weight. A weight is simply a number that tells the network how important a particular input is. You could think of weights as stored knowledge. The network combines inputs with weights, applies activation functions, and passes the result forward layer by layer. Finally, we reach the output layer, where the network produces a prediction. In this example, the output is a probability, like dog, 0.9, cat, zero point 0.1, rat, zero point 0. This means the network is 90% confident the image is a dog. Now, how does a network actually learn? This happens through a process called backpropagation. Backpropagation works like this. First, the network makes a prediction, then it compares that prediction with the correct answer and calculates an error. That error is then sent backward through the network layer by layer. Based on this error, the weights are slightly adjusted so that the next prediction becomes better. This cycle, predict, measure error, adjust weights, happens millions or billions of times during training. Over time, the network becomes extremely good at recognizing patterns. Now, to connect this to large language models, the largest version of GPT-3 has 96 hidden layers, built using stacked transformer decoder blocks, and around 175 billion parameters. A parameter is simply a value the model learns, mostly weights and biases. More parameters mean more capacity to store patterns and knowledge. So when you talk to ChatGPT, you are interacting with a massive neural network that has learned language patterns from enormous amounts of data using these exact principles. In short, individual neurons are simple. Intelligence emerges from large-scale connections, and learning happens through backpropagation. This is the foundation of modern AI.